Alright, sorry guys, this is taking so long. This is the third video, R6c, and I'm getting real tired of talking, but we'll see if I can keep my energy up so I don't bore you too much. We're on example 6, square root of x minus. Okay. So in this case, what we're going to do is we're going to rationalize the numerator. We're going to try to get rid of the radical signs in the numerator. And it's basically the same thing. You're just trying to figure out how to get rid of the radical signs in the top numbers instead of the bottom numbers. All right, in this case, we have two terms that are locked together with a minus sign or a plus sign. Remember, plus and minus signs locked together. So we're trying to get rid of this radical. One of the ways to get rid of radicals or to change things is to multiply by what's called a conjugate. If you remember from past math classes, a conjugate is a set of numbers that are the exact same. The only thing that's different is the sign. So because this is a minus and this is a plus, these are conjugates of each other. So we're going to multiply the top and bottom number by the conjugates. And what happens when you multiply by the conjugates is when you use the FOIL method here, like you would when you multiply this. Let's put parentheses here so you can kind of see FOIL a little bit better. When you multiply these, whenever you multiply two radicals by themselves and they're the same radical, square root of x times square root of x, the radicals disappear, and that's what we want. And the second number, when you multiply square root of y times square root of y, the radical disappears, and that's what we want. Also, conjugates, when you multiply the two middle terms of FOIL, the o and the I, cancel each other out. So, let's go ahead and write it in FOIL and show you what I mean. Square root of x times the square root of x is square root of x squared. The outside would be square root of x, square root of y. Okay, you can't combine those because there's two different variables under there. So square root of y, square root of x. Inside. And last. Whoops. Okay, look, these, one's a plus, one's a minus, those go away. This becomes x, this becomes y. So the numerator then changes to x minus y, and the bottom, you have to go ahead and multiply by that there from here. So you get x minus y over that for an answer. X minus y over 5 square root of x plus 5 square root of y. Okay, so one of the things that you can do, I went through this whole bit here of using the FOIL. If you're good enough and you recognize that you've got those conjugates, you square the first term, square the last term, and put a minus there and you're done. Whenever you multiply by conjugates, square root of the first term, you square the first term, square the second term, and put a minus, always a minus. And that saves you from doing a lot of extra work, but it doesn't hurt to keep doing the FOIL method if it feels like you're doing better doing the FOIL method instead of trying to do stuff in your head. I still see kids in math when they get a number like 3 plus 5, just to make sure they plug that in their calculator to see if they get 9. And hopefully they get 8 when they put it in their calculator. So anyway, let's jump down to rational exponents. And rational exponents are basically exponents with fractions in them. And they're kind of, okay, so I'm a math nerd, they're kind of fun to mess around with. And so what we've got here is a 16 to the 1/2 power. You've got a fractional exponent there. What that means is the top number is the exponent of the 16. The bottom number is the index. So what this means in radical form is that. Okay, there's my top number, there's my bottom number, and my 1/2. Okay, so basically what this means is the square root of 16. Sometimes you might get something like and then write it in radical form, 27. And the exponent is a 2, and the radical, or the index, is 3. So what we're going to do then is I'm just going to rewrite this as like that. Put the 2 outside. Cubed root of 27 is 3. Squared equals 9. So this mess is actually just the number 9. Okay, so we've been doing those in Algebra 2 and some of the other algebra classes maybe you've taken. But one of the key things that I wanted to remind you of is if you have something, again, like this, write it like, bring that 2 out there, just like that. Those are equal. It makes it so it's a lot easier than to take 27 squared and then try to cube it. It's easier to take the cubed root of it. It's easier to take the cubed root of 27 and get 3 and then square it. Alright, if I have like 6 to the 1/2 power cubed, power rule says that that's 6 to the 1/2 times 3, or 6 to the 3/2. Okay, so don't forget, multiply. Use the power rule and multiply. And that brings us to page 44, top of the page, where we're doing some rules there as far as rational exponents are concerned. I write those down in my notes, especially the third one. So let's do some examples here and see if I can get done with this lesson in 3 videos. 7 to the 3/4 power. What are they asking us to do? Convert to radical notation, and if possible, simplify. So this in radical notation would be 4 to the 7 cubed, or 4th root of 7 cubed, if that helps you. It doesn't. Neither one of those help me, so I'm just going to leave it like that. It can't be simplified. 8 to the -5/3. Remember that negative just means that the 8 and 5/3 are in the wrong place. So I'm going to put it down here and make it a positive. And that's going to equal 1 over cubed root of 8 to the 5th power. Cubed root of 8 is 2 to the 5th power. 2 to the 5th power then is going to give me 32, 1 over 32 if you know German. Okay, so that's the B part of example 7. Let's go to C. M16. Index is 6. M. Okay, and that's as much as you can do. Let's go to D. -32 to the 2/5 power, which means we have a 5 there, we have a -32, and we have a squared. So notice I normally take that 2 and put it clear out there, because usually I can take the index of what's inside there. So the 5th root of 32, and remember, because my index is an odd number and that's negative, then that's doable, and that's going to give me 2, or -2, I'm sorry. -2 times itself 5 times is -32. I'm going to square that, and that's going to give me 4. Alright, so let's jump to example number 8. In example 8, it gives me 4 examples. I'm so tired of all these examples. 4th root, and we're going to take that to the 5th power. Alright, so convert each to exponential notation, so we're going the other way. So we're going to write that as 7xy to the 5/4 power. We're just starting out, we're going that way. Alright, B, 6th root of x cubed. That gives me x to the 3/6, and 3/6 reduces to 1/2. So this is the same as x to the 1/2 power, or the square root of x. All right, ready for lesson or example number 9. X to the 5/6 times x to the 2/3 is x to the 5/6. What do you do with exponents? You add them when it says multiply. That means you find common denominators. Okay, you end up with an answer that looks like that. Well, 9 over 6 reduces. Okay, and it not only reduces, but let's go ahead and write that in radical form. Okay, that doesn't help me. But what does help me is this. Because then I can go, oh, 2. 2 goes into 3 one time with 1 left over. This then is the simplified version. So see, sometimes this way helps me to solve it. Sometimes this way helps me to solve it. And one of the key things, this way helps you to solve it almost exclusively when there is a number under here and you can actually take the square root of it and cube it. If there's just a letter under here, then it usually works better to keep your exponent underneath here so that you can go 2 goes into 3 one time with 1 left over and simplify it that way. So those are two key things when you're doing these, very important here. Okay, and notice this. The only reason we can combine these two here is because what's inside the parentheses is the same. So because these are being multiplied, I add these, right? I can write it as plus negative 1/2 or just minus 1/2. And fortunately they have common denominators. 4 over 2 is 2. Okay? One more, C. And these are not as hard as what they appear, the cubed root of the square root of 7, because what we're going to do is we're going to write them as exponents. So let's just we start on the inside, and then we start working our way out. Okay? So I took the square root, made 7 to the 1/2, cubed root, made it 1/3, and because of the power rule, I get 1 over 6 for my answer, or the 6th root of 7. Okay, so this example 10, top of page 45, easy to miss. Write an expression containing a single radical. So what we're trying to do is change this to radical form and putting it under one radical sign, because right now it says a single radical. Right now we have the square root of a times the 6th root of b to the 5th. I have two radical signs. They want it to go under one radical sign. But what's the problem? The problem is this is a square root and this is a 6th root. So in order to make this work, I'm going to have to turn this into a 6th root. So how do I change 1/2 into the denominator being a 6? Well, I write it as 3 over 6, right? 1/2 is the same as 3 over 6. Now I have the denominators the same, so I can write the 6th root of a cubed b to the 5th. And I'm done. And that's it for the review exercise 6 after 3 videos, and holy smokes, about 42 minutes. All right, so I'm going to stop there. And you'll just have to ask me questions over the lesson. I don't want to keep going into hours and hours on this video. So that's it for review point 6.